Questions we'll answer in this lesson are: what is force, what is pressure, what is water head, and how many psi is 1 foot of head, and how do I solve problems involving force, pressure, and head. Well, first let's take a look at what force is. Force is the push exerted by water on any surface being used to contain it. So here we have a container of water, and it's basically just the force that's exerted on any side, bottom, any part of the container that's containing water. And it has units of pounds. So it's pounds force, or units of pounds. Pressure is force exerted over a specific area. So in our example, here we have this force being exerted on the bottom of this container or this tank. So there's a certain number of pounds per surface area. Typical units are pounds per square inch. So PSI, pounds of force per square inch of surface area. Water head is the vertical distance from the water surface to a reference point below the surface. So here we have a water tank, and we have some water level in this water tank. So if we have 80 feet being the difference between the surface of the water in this water tank and the reference point below, we have some amount of head, and in this case it's 80 feet of head. So the units of head are feet. Well, how many psi is 1 foot of head? Or how many pounds per square inch is 1 foot of head? Well, 1 foot of head is equal to 0.433 pounds per square inch. This is an equivalent that can be used to convert units, and it's worth memorizing. So remember that 1 foot of head is equal to 0.433 pounds per square inch. So here we have a container. It's got 1 foot of water in it. If we were to measure the pressure at the bottom of this container, we would see that the pressure is 0.433 pounds per square inch. Now it doesn't matter the diameter of this container. It could be 100 feet across, or it could be just a couple inches across. That 1 foot of water head will give us 0.433 psi. Well, how many pounds per square foot is 1 foot of head? So in that example, we have just 1 foot of head. Well, instead of being in psi, 1 foot of head is equal to 62.4 pounds per square foot. So this is a different way of expressing pressure. Instead of pounds per square inch, it's pounds per square foot. And we could just take our pounds per square inch and convert it to pounds per square foot, and that's what we'll do here. So when we convert PSI to pounds per square foot, we come up with 62.4 pounds per square foot. And you can hopefully see the relationship between this head, this 1 foot of head, and a cubic foot. If we give it that other dimension, we'll have 62.4 pounds per cubic foot. So there's the relationship between pressure and the weight of a cubic foot of water. Well, how do you solve head problems? Well, here we have a problem showing that we've got 80 feet of water level in this tank, so we have 80 feet of head. How do we determine how much PSI, or how much pressure we get from that 80 feet of head? Well, we simply do a unit conversion using the equivalent that says 1 foot of head is equal to 0.433 psi. So we're going to take our 80 feet and we're going to load it into our monorail, and we're going to do a unit conversion. Well, since I have 80 feet as my driver, I'll put 1 foot on the bottom and the 0.433 psi on the top. And my feet will cancel out. So now I multiply 80 times 0.433. And that'll give me 34.6 psi. So you can see that with 80 feet of water head, you have almost 35 psi, which is typically the minimum that you would want in a water system. How do you solve force problems? Well, here we have a tank that's underground, so it's partially buried. So the majority of this tank is below grade. Then you can see here that we have some groundwater level that is above the bottom of the tank. Okay, so there's groundwater within the soil surrounding this tank. That's going to cause an upward force on the bottom of this tank. Okay, the water head, the groundwater, is going to cause this tank to want to come up out of the ground, and it's going to cause a force trying to push it up. Well, how do we calculate the force exerted on groundwater on the bottom of a tank? Well, we need to know how many feet of head above the bottom of the tank we have. So here we've just given this 10 feet. So in this case, groundwater level is 10 feet above the bottom surface of this tank. We also need to know the area, or the surface area, of the bottom of the tank. With the head and the surface area, we can use this formula to calculate the amount of force in pounds that's being exerted on this tank. So the formula is 62.4 pounds per cubic foot times the surface area times the feet of head that the water level is above the bottom of the tank. So this here's the formula we'll use to calculate force on the bottom of the tank. So in this case, we'll take 62.4, multiply it by the 700 square feet of surface area times the 10 feet of head, and we can see that there's 436,800 pounds force being exerted on the bottom of this tank. So what that means is the combined weight of the tank and any water in it and friction from the soil on the side of the tank has to exceed this force. Otherwise, the tank is going to try to come up. It'll move, and that shifting of the tank can actually snap a pipe. So when tanks are emptied for cleaning or inspection and there is groundwater above the bottom of the tank, it's important to do a calculation to make sure that you're not going to have that tank try to move or float up out of the ground on you. Well, example number 1 reads, and I want you to follow along and write this down on your handout so you'll have it to refer back to when you're working your sample problems. But example number 1 reads, how much force would be exerted on the bottom of a 1-foot cube if it was full of water? Calculate the PSI at the bottom as well as force. So first we're going to calculate the force. Okay, so our force formula is 62.4 pounds per cubic foot times the area times the head. Well, the area of a 1-foot cube, it's 1 foot by 1 foot, so the surface area is 1 square foot, and the feet of head is 1 foot. So the force is 62.4 pounds. Okay, so that's, I mean, there it is. That's no surprise. We know that a cubic foot of water is 62.4 pounds, and if it's sitting on a square foot, we know that it's going to be 62.4 pounds. Well, how do we convert that to PSI? Well, the square foot converted to inches, you'll take your 12 inches times 12 inches to get the surface area in square inches of the bottom of this cube, and that comes up to 144 square inches. So 62.4 pounds, that's how much water is being exerted on this surface area of square inches, 144. We divide that out, and that comes out to 0.433 psi. So you can see that this is kind of circular reasoning, but this is an example of where that 0.433 psi comes from. Example number 2 reads, find the upward force on the bottom of a partially underground tank that has a bottom surface area of 400 square feet. Groundwater level is 5 feet above the bottom of the tank. We'll use our force formula. So pounds force equals 62.4 times area times head. So now we're just going to plug in our numbers and do this math. So 62.4 times 400 square feet times 5 feet of head equals 124,800 pounds. Example number 3 reads, convert 45 feet of head to PSI. Well, this is just going to be a straight conversion. Our driver is 45 feet, and now we're going to use the equivalent that says 1 foot of head is 0.433 psi. So since I have feet on top, I'll put the 1 foot on the bottom and the 0.433 psi on the top. That allows my feet to cancel out, and now I just do the math. So 45 times 0.433 psi equals 19.5 pounds per square inch. Now if I'm going too fast on these problems, go ahead and pause the lecture and write it down. I want to make sure you get this written down on your handout. That way you can refer back to it when working your practice problems. I'm going to point out here, a lot of operators know this equivalent, and they'll ask me regularly, well, what about 2.31? Well, 1 psi is equal to 2.31 feet of head. And if you prefer to use this equivalent, if this is what you've memorized and you want to use it, that's fine, but let's just keep the units straight. So if we're to do this problem using the 2.31 feet of head as 1 psi equivalent, it would look like this. Since we have feet on top, the 2.31 feet needs to go on the bottom, and the 1 psi needs to go on the top. So in this case, we would take 45 and divide it by 2.31. The units will cancel just like before, and you're going to come out with the same answer, 19.5 psi. So whether you use the equivalent 1 foot is 0.433 psi or 1 psi is 2.31 feet, they both work. It's just you have to keep the unit straight so that you know whether you're dividing by 2.31 or multiplying by the 0.433. Well, now it's your turn to work those practice problems. Work every problem. Don't take any shortcuts. Carefully work each problem, set them up, use the monorail as required, and then check them against the answer key. And once you're confident that you know how to do these types of problems, take the quiz, and I'm sure you'll do well.